3. Unit 6. We'll discuss a question from this unit. Question 2. In this question, this is Unit 6, okay? January 2023. Okay, it's fine. The reaction between a tertiary halogenoalkane and a tertiary halogenoalkane, which is 2-chloro-2-methyl-propane and a hydroxide to form 2-methyl-propane-2-ol, is shown. The progress of a reaction can be followed by titration portions of a reaction mixture with a solution of a hydrochloric acid of a known concentration. So what we did, we remaining like the reaction happened because that alkali which is present will react with a hydrochloric acid, and we work out the rate of the speed of the reaction, the progress of a reaction. Then an experiment to determine the order of a reaction was carried out. We are finding what is the order of this reaction, first order, second order. In the procedure, first we take a flask, 250 cm cube of ethanolic solution. Ethanolic solution means like a solution which contains ethanol, and 2-chloro-2-methyl-propane. And with a concentration 0.1 mole per dm cube was placed in a water bath for 25. Okay. Good. Now, because the idea is that the ethanol, because the solubility of a substance vary in different substances. Like this is a halogenoalkane. Halogenoalkanes are not water soluble. Does not dissolve in water. So alcohol is a solvent which is used to dissolve both sodium hydroxide, aqueous sodium hydroxide, because alcohol and water can mix with each other. So if I add aqueous sodium hydroxide, it will have alcohol as well. No, alcohol is there, and I will add aqueous sodium hydroxide, so I will have a common medium. Otherwise, if I was having aqueous sodium hydroxide, and I was adding this halogenoalkane, they won't mix with each other. Okay. So alcohol is acting like a solvent for both of them. It's like a medium in which both can mix. So, like the product of the reaction will be reacting with the halogenoalkane? No, not the product. We have aqueous sodium hydroxide, which contain a sodium ion and a hydroxide ion. Okay. We have a halogenoalkane. We want to react them together. But the problem is they cannot mix with each other. Okay. So alcohol is used as a solvent here, so that both mix in the same substance and can collide with each other and form a product. So I mean, like with the sodium and the other product, it's like a medium of the sodium hydroxide to dissolve, so it can react with the yeah. Because in that both are soluble. What will happen? What's new when the sodium? If you use aqueous sodium hydroxide in this, they will not mix with each other because of the difference in density. Aqueous sodium hydroxide will remain at the bottom, and the tertiary halogenoalkane will remain on the top. So what's the change of the output? Huh? So what's the change of the output? So what alcohol will do? Alcohol will act as a solvent. So when we add an alcohol can dissolve both water, like mix with water, and with halogenoalkane. So both particles can now combine with each other. Particles from halogenoalkane move and combine with each other with the hydroxide. So alcohol is a co-solvent. Co-solvent means a solvent which can dissolve both sodium hydroxide and halogenoalkane. Then a similar flask containing 250 cm cube of a sodium hydroxide with a concentration 0.1 mole per dm cube was placed in a water bath. Okay. And the temperature for each solution was allowed to reach 25. Because for investigating a rate or a speed of a reaction, rate can be affected by temperature. And we want to determine the order, keep the conditions same like the concentration, the temperature. That's why we use a water bath here. Okay. Then in step 2, 7 conical flasks were placed. In each about 50 cm cube of a propanol is added. Which one? 7 flasks are there, and each we add about 50 cm cube of propanol. Then the reaction was started by mixing a 2 solution from a water bath in a large flask. This is one solution. and this is sodium hydroxide, another solution. The flask was returned to the water bath, and then a timer was started as the solution were mixed. And then at an interval, 25 cm cube of a sample of a reaction mixture was transferred into a conical flask containing a propanol. Okay. Yeah. And then time was noted. Each sample immediately titrated with hydrochloric acid of a concentration 0.05 using methyl orange as an indicator. Now, so what we did in this reaction, propanol is also added in the mixture. What is the purpose of a propanol? Propanol is like example, when some reagents are there, they're quenching as well. Like, do you see propanol here? Any reactant? No. So what is the purpose of the propanol? Is to quench the reaction. Quench the reaction means stop the reaction for further change. Because when we add a propanol will dissolve halogen alkane. So they are separated from each other. When they are separated from each other, now the sodium hydroxide can be titrated with a hydrochloric acid. Clear? So it is already there, ethanolic solution. This was mixed. If you read the question, a flask contained 250 cm cube of ethanolic solution. Mean that is alcohol. No, ethanolic means alcoholic, ethanol. Okay. So this contains ethanol, this contains water, we mix them together and then we mix them in a large container. Huh? Aqueous. So acid and alkalis are always with water. So we mix them in a flask, okay? And then we take out a sample and transfer it into a small conical flask. When we transferred them into a conical flask, the conical flask was containing what? The propanol. So what is the purpose of the propanol? The propanol was a quenching agent. Quenching agent means like slow down or stop the rate of reaction. Like quench the reaction. Give an expected color change at the end point. Look, in the solution, we have alkali. OH is there. Because in a flask, we have OH. And then we titrated with a hydrochloric acid. And always the indicator is added what is there in a flask. So flask contains OH and there is a methyl orange. What is the color of methyl orange in acid? Alkaline medium? Yeah, alkaline medium. No. Methyl orange. Yellow. Alkaline. And when it is neutralized, it will turn into, when we add a hydrochloric acid and we form a neutral solution, what is the color? The color will be orange. So it will change from yellow to orange. If it was acid, then it will change from red to orange. Like if the flask was containing an acid, then original color will be red. And when you add an alkali, you neutralize, so the neutral solution will be orange. That's methyl orange. So the question is from stopping the halogen alkane from halogen alkane from alcohol to react with each other. The halogen alkane and OH ion from the sodium hydroxide will not react. That's why we quench. The next, explain why explain the effect on the volume of a hydrochloric acid required if the titration was not carried out immediately after step 4. So if you don't carry out the titration immediately, what will happen? What will the effect? Because this OH ion is reacting with halogen alkane. Okay. So if immediately we don't do a titration, like in a conical flask, we allow this substance to be there in the conical flask. Okay. And then we did not add immediately. So what will happen? Because this solution also contains halogen alkane. So this halogen alkane will react with the OH. So amount of OH will decrease. So what will happen to the amount of the titer, the hydrochloric acid which we need? We need more or less? No. Do we need more hydrochloric acid or less hydrochloric acid? If we don't carry out the titration immediately. Means instantly. Like once you remove a sample, if you don't carry out the titration immediately, what will happen? Yeah. So if OH will react with the halogen alkane, amount of OH will decrease, so amount of hydrochloric acid needed will also decrease. We need less hydrochloric acid because if we carry immediately, we need more. But if it is not carried immediately, less. Because the OH will be decreasing. Because if you carry out immediately, you need more. But if you don't carry out immediately, you take some time to carry out titration, then the amount required will be less. Because the hydroxide concentration will decrease. Next is explain the use of aqueous ethanol in the mixture. Allow the reaction in step 3 to proceed relatively faster rate. A description of forces are not required. Look, we just discussed now what is the purpose of ethanol. Ethanol is what? It's a co-solvent. Co-solvent means like it can dissolve both because the main reaction is between the halogenoalkane and the sodium hydroxide. But the problem is that this halogenoalkane does not mix with sodium hydroxide because halogenoalkane is an organic compound which has a dipole force where sodium hydroxide, which is aqueous sodium hydroxide, which is having ion dipole force or hydrogen bond. So the bond between themselves would be only dipole. So the thing is, they won't mix with each other. So what is the purpose of ethanol? It is used as a co-solvent. Okay. So the points here which will score mark, ethanol is a co-solvent and use ethanol, allow the reaction to mix with each other. But we don't have to say about anything about the intermolecular forces here. The experiment was carried out using this procedure, and the results are there. Volume of a hydrochloric acid. So volume of a hydrochloric acid and time. So if we have this, if a volume of a hydrochloric acid needed, if it was a straight line, what does it mean? Which kind of reaction will be? If it's a constant change, constant slope means zero order. Constant slope means like a rate is not affected by the constant. If it was a first order, then it will be like this curve. So we have to sketch this result, expected result from this graph. That's first order. If it is a curve, a drastic change is there. If it is like this, first order. Volume graph or a yeah, it's the same idea. Concentration, because they have the same concentration, so the ratio of the volume is same as the ratio of the concentration. If I need more volume, it means I need more moles for that. No, I don't know there was increasing. Yeah, that is a concentration rate concentration graph. Determine the two successive half-life. So how we determine a half-life and state the order. Look, how do you determine the half-life from your graph? When once you sketch a graph, you will have your results. So you will determine, like example, say this is a first value. You will take half of it. That will be the second value. And the interval will be a half-life. Okay. And then you can take this, any other two values you can take, or you can take the second and the third value. So let's say you took this value and you took another value, and you also worked out the half-life.
So,
Yeah.
how would the second order of this could be?
If it is a second order, if it is a first order, then the half-life will be constant. But if it is a second order, initially the half-life will be shorter, but then it gets longer.
Like in terms of the shape of the slot, they would be the same.
If it is a first order, yeah.
Yeah, in this case, the first one is going to shape will be the same.
Shape will be same, but using the half-life you can determine. If the half-lives are same, it's the first order. If half-life is getting longer, it is a second order.
The zero order is the same as the rate, concentration now. The zero order.
Zero order, it will be a horizontal line.
Same.
Yeah. Not horizontal line. It will be because the constant gradient. Because the slope rate, concentration time graph, slope represent the rate. So if a rate is constant, it will be a straight line. Like if it was a zero order, then what will be the shape of the graph? It will be like this. If it is a first order or a second order, it will be a curve. But first order half-life will be constant. Second order half-life will get increasing half-life. So this was a 10-mark question.